Welcome back. Today we're talking all about hydrohalogenation reactions and how we can use Markovnikov's rule to help us determine the products. So here I have a simple alkene. This is a shape that has a double bond in it, and the functional family is called alkene. Hydrohalogenation reactions will usually need to start with either an alkene or an alkyne, which is a triple bond, and we'll do those examples in a future video. These type of reactions will take a hydrohalogen as the reagent. It's easy to remember because the word hydrogen points to the H, and the halogen points to a halogen, which could be bromine, chlorine, iodine, and so on. So HBr, HCl, HI are some examples of the reagents that you could be using. In order to predict your products, the first thing I would recommend is to label the carbons that make up your double bond, which are the two green dots on the original shape. Label these as carbons 1 and 2, and on each carbon, remembering that carbon can only make up to 4 bonds, both carbons 1 and 2 would only have space for one extra hydrogen to get to 4 bonds. Draw in all of these invisible hydrogens on the original shape. And now to make your product, draw the exact same shape, and now erase the double bond from the product. Now draw two sticks coming out of the carbons that originally had the double bond there, which were your carbon 1 and 2. Your H and your Br from your hydrohalogen will be going on those red sticks, but you have to figure out which one goes where. This depends how many hydrogens are originally on each of those carbons, and in this case you do have one hydrogen on both, so it really doesn't make a difference whether you put H on the top red stick and Br on the bottom, or vice versa. Now, there will be cases where your shape is not symmetrical, and we will discuss those, but in this case, it doesn't matter which way you put the H and which way you put the Br. So we can just leave our final answer like this. Now let's say we have a second example where the shape is not symmetrical, like this one. We just have one hydrogen on carbon 2, but carbon 1 has another group instead of a hydrogen at the top. So we would do the same steps. Draw the exact same shape from the very beginning and erase the double bond. Now out of carbon 1 and 2 that originally made up your double bond, you're going to draw two sticks popping out in red. Your H will go on one, your Br will go on the other. And in this case, it does matter where they go because you have a different number of hydrogens on both carbons. This is what Markovnikov's rule is going to help you determine. So this rule states that hydrogen goes where his friends are at. And what that means is which location has more hydrogens. Is it carbon 1 or carbon 2 that made up the double bond? It was carbon number 2. And that's where the new hydrogen coming from the HBr is going to be placed. So the Br would be added on top and the H would be added on the bottom in your final product. And that's all for today. Thank you for watching.